First up today, we're going to talk about that baseball question with the home run. So you hit a home run in the jungle, you hit a home run in the desert. Where does it go farther and why? Okay, it will actually go farther as long as there's no net condensation on the ball or rain in the air or fog in the air. It will go farther in the jungle. It'll actually go farther in the jungle. Now that's completely counterintuitive. Okay, why is that counterintuitive? Because a lot of people, when they're talking about when it feels humid outside, they'll say it feels sticky or close. So that makes you think the air would be more dense. Also, your experiences with liquid water. Liquid water is indeed 1,000 times denser than air, approximately. Okay, you try to run your hand through a bathtub, there's a lot of resistance there. So liquid water is absolutely way denser than air. The issue is we're talking about an increase in water vapor, water in the gas form. Okay, so what happens when you increase the amount of water vapor in the air? Well, here is the percentages of nitrogen, oxygen, argon, CO2, neon, helium, methane, water vapor. It says 0. 0 is not possible. Something slightly greater than 0 up to 3%. But there's the composition by percent of what makes up the air. And when you make the percentage of the water vapor go up, okay, in the jungle, a higher percentage of water vapor because the dew point is higher. Higher dew point means more water vapor in the air. As you make the amount of water vapor go up by percentage, everything else has to go down. Now, you can do a little chemistry and convince yourself of this if you want. You can look up some molar masses and stuff like that. But as the water vapor goes up and this other stuff, this nitrogen, oxygen by percentage goes down a little bit, the overall density of the air actually goes down. And many of you argued that there'd be less air resistance at the desert based on the density. A good argument, you just got it mixed up or didn't know yet, okay? Very few people do that. When you have more water vapor, very counterintuitive, the density of the air actually goes down. And then yes, the less dense air, the ball flies farther. So it'll go farther in the jungle, everything else being the same. But anecdotally, I have noticed this with golf. Back when I was really good at golf, I could notice a difference on a really humid day versus a really dry day, everything else being equal. And a couple yards one way or the other, 10 yards plus or minus on a golf shot can be a big deal. If you're really into statistics and baseball, I bet you could go through and analyze and adjust for things and show that not only will the ball go farther on a humid day, but there's probably more home runs if you account for everything on humid days. Okay, which we'll talk more about here in a minute. Humid days being the higher dew point days, where there's actually more water vapor in the air. All right, so that was the quick thing for the baseball question. Okay, now let's go to public service announcement here for dew point versus relative humidity. Okay, so I've pulled up here, this is from today, from my today, the 27th of April 2020. Okay, but let's take a look at and these are either actual, this is either the maps we're looking at either have actual data plotted or the forecasted data for the rest of the day. Okay, so pretty close to what will happen, not that far out. Okay, so let's start by taking a look at relative humidity at 8 a.m. Okay, for April 27, 2020, 8 a.m. Eastern, so 7 a.m. All right, so let's take a look here for Kansas City. We're somewhere in the 70 to 80%, okay? As is much of the country. A little bit lower out here, a little bit higher up here, but most of the country, the relative humidity is within, 10, 15% of each other this morning, okay? Now, what's going on? Hopefully you don't think that it feels the same in southern Florida down in Key West as it does in northern Montana or northern North Dakota in the morning, okay? If you're waking up this morning on the beach in Key West, I can guarantee it is going to feel more humid than it does along the Canadian border, okay? So this is the first thing to be like, hey, something's up here. Relative humidity is not going to tell you how dry or humid it will feel outside to a human being. Okay, now if you are a future pilot, meteorologist, possibly farmer, you might care a lot about relative humidity. Relative humidity does have a use, okay, because it's going to tell you it's a ratio, has to do with the ratio of the temperature and the dew point. So it'll help you figure out when you're going to get net condensation, which can help you figure out clouds or stuff for crops. But for human comfort, you don't care about this number, okay? The temperature of your skin is going to be about the same. It has to do a heck of a lot more with what is the dew point outside. Now let's look also at relative humidity throughout the day here. So as the day goes on, you'll notice relative humidity across the entire country goes down, okay? Almost all across the country. Why? Because as the temperature goes up, so this is my dew point, this is my temperature. As the temperature goes up, the higher it gets above the dew point, the lower the relative humidity. That does not mean that Central Florida is going to feel dry this afternoon, okay? In fact, quite the contrary, okay? Central Florida will probably feel very humid, okay, and hot this afternoon, okay? That is not somewhere I would want to be, okay? So as the temperature goes up and the dew point stays about the same, relative humidity will go down. That's why it's going down across the country. It does not mean that it's getting drier, though, okay? Now, why is the temperature going up across the country? The sun. The sun came up this morning, and where you don't have a ton of clouds, temperature's going up a whole bunch, okay? All right, so now that does not tell us how we're going to feel. Let's take a look at dew point. And remember, dew point is actually proportional to the amount of water vapor in the air. Okay, if you increase the amount of water vapor, the dew point goes up. If you decrease the amount of water vapor, the dew point goes down. And throughout the day, minus any fronts moving around, okay, or wind shifts or things like that, the dew point across the country probably stays pretty much the same. There are going to be shifts, like I said, if there's a front or a wind shift direction or something like that. But let's take a look and see if this is a better judge. We're talking about this for human comfort. This is not a meteorology class. Okay, so for human comfort, if you wake up in Key West this morning, oh my gosh, or down in Houston, the dew point is in the upper 60s to mid 70s, it looks like, okay? In fact, a lot of places down here along the Gulf of Mexico have high dew points. There's a large body of warm water there compared to other bodies of water, okay? And those high dew points are what will make you feel humid, okay? To me, personally, dew points in the 70s are when I want to stay in the house. I don't really want to venture out. I certainly don't want to go outside and exercise or anything like that. If the dew point's in the 70s, that feels humid to me. In fact, even upper 60s starts to feel a little humid, but low 70s to mid 70s is bleh, okay? Now, if you look for Kansas City, Missouri this morning, okay, and again, this is for where it's Monday morning, okay, so if you're watching it this year, you can just think back to yesterday morning. We've got dew points in the 40s and the 50s, okay? That's, to me, like perfect, okay? That's, when you have dew points in the 40s and 50s and even upper 50s, that feels amazing, okay? Dew points that are very, very low in the teens and negative dew points to those, they start to feel dry to me. And this is just my personal opinion on this, okay? So you might say, I don't know what dew points feel like to me. That's because you haven't been paying attention to dew points. Your entire life, you've built up your own personal database of temperatures. If I said tomorrow it was going to be 95 degrees, you'd be like, oh, wow, that's hot, right? Okay. If I said tomorrow for this time of year, if I said tomorrow it was going to be, 40 degrees, you might be like, oh, 40 degrees Fahrenheit. You might be like, oh, that's going to feel cold to me this time of year. You know that because you've been paying attention to temperatures your whole life. If you start to pay attention to dew points, instead of relative humidities, things will start to make sense. You'll be like, oh yeah, dew point of 40. It's not too bad. Or dew point of 5. Oh, it's dry. I'm going to probably want some lip balm or whatever, okay? Or dew point of 74. You'll be like, oh no, it's going to be really, really humid. I don't want to go outside. If you start to pay attention to dew points, the stuff will start to make sense. Similar to the way you pay attention to temperatures, how windy it is. You can look at numbers for wind. If I say we're going to have 20 mile per hour winds tomorrow, for most of you, they'd be like, oh, that's going to be kind of windy or very windy. And like sun versus cloud cover. All right, start paying attention to dew points and you'll build your own database and be better prepared to go outdoors. Now let's also advance the dew points throughout the day here. And you'll see dew points up here in Canada. We've got 20s, 10s, teens maybe. Looks like here we have some negative dew points, okay? So it could be some frost there this morning, okay, not frozen dew. Here in the mountains, we've got some pretty low dew points as well. And then, like I said, for us, basically perfect right now, okay? All right, so let me go ahead and advance this to 11 a.m. See the dew points change some. Some of this is because it's a forecast now and not the actual data. But look at 2 p.m., look at 5 p.m. The overall idea here is still the same. Here we're along the Gulf Coast, high dew points. Up here along the Canadian border, low dew points. It actually tells you how you're going to feel. Have a good day.